Welcome to Maths Entry. This is 2026 January Edexcel IAL P1 paper. Let's move on to the first question. Y equals 4x cubed plus 3 over 2 root x minus 8. X is greater than 0. Find in simplest form plot A dy by dx. You are getting 3 marks for this. So when you're asked to get dy by dx, the very first step, you got to check whether it's been given according to a certain format. It means you have to check whether everything is set to differentiate. Now, in this case, you have to check whether you need to rearrange this one or not. It means everything is set straight away, you can differentiate or not. In this case, can you see you are getting root x here in the denominator? If you are getting any x terms, any x variables in your denominator, you can't do differentiate straight away. You got to rearrange it. Let's rearrange this one. How do we rearrange? Root x, you need to convert it into index form. How do we convert? Root x, wherever you see third root, this one, you need to convert it. Let's say this is root x, then x, you need to get it x to the power of half. Wherever you see third, you need to convert it into an index form. Index means you need to convert it into a power of something. So let's convert this one into power of something. That's the very first thing. You can't have any third form in your equation. So you need to get rid of all the third forms. Let's get rid of y equals 4x cubed plus 3 over 2. Here I'm getting third. I need to get rid of then x to the power of half. Done of that one, minus 8. Okay, right. The next thing is you can't have any x terms in your denominator. You need to get rid of them as well. So first thing, you can't have any third form in your expression or equation, and you can't have any x terms in your denominator. You need to get rid of them. You need to chase them out. So let's chase them out. So when I'm chasing them, they are changing. What will happen to them? You need to change their power into negative. If they are already negative, you need to change them positive. If they are positive, you need to change them negative. You need to switch their sign. So I'm changing y equals 4x cubed plus 3 over 2 x to the power of minus half minus 8. Now, there are two important facts that you got to remember. Some students, they tend to take these numbers also to the numerator. You should never take them to the numerator. And some students, they tend to switch this power. We switch the power when we are getting like this. When we are making a fraction, a positive power, yes, we switch the numerator and denominator. But when we are like switching the numerator and denominator like this, you don't switch the numerator and denominator of the power. Here, of the power. You switch power, the number itself. Got it? Right. Now, we are all set to differentiate. Now, dy by dx equals, how do we differentiate? You need to remember this stuff. Axn, let's say that we need to differentiate this one. What the hell this is? Okay, let's get it like this. 3x5. How do we differentiate this one? You have to start off with the power, which is 5. Since I'm having here another number, I need to get that one as well. X, I need to subtract one power. That's the rule. You have to start off with the power and you need to take away from the power. If you are just having like this, it is just 3. If you are just having, this is dy by dx, okay? If you are just having a single number, it is 0. Right, in this case, now I got to get the start from number 3 into 4 x. I need to take away from the power. Then 3 minus 1. All clear. Then minus half into 3 over 2 x minus half minus 1. Now this is just a number here. According to this one, it is 0 because we can't differentiate just a number. It is 0. Right now, let's multiply 3 into 4, guys. It is 12 x. 3 minus 1, it is 2. So it is 12x squared minus, because here plus minus minus, it is 3 over 4. It is 3 over 4. 3 over 4 x minus half minus 1 minus 3 over 2. This is the answer. Let's go to the part B. Part B, integrate. So we need to integrate the same equation. So let's write it first. Integral of y 4x cubed plus 3 over 2 root x minus 8. As same as differentiation, if you are getting an expression or equation, check out whether you have to rearrange. Why? You can't integrate when you are having anything in the denominator in any x terms. If you are having any x terms in the denominator, if you are any third terms, you can't integrate. You need to get rid of them. So first thing, rearrange. So we've already rearranged, right? So we can straight away use it. So let's straight away use it. So I'm using it. 4x cubed. So here apply dx plus 3 over 2 x to the power of minus half minus 8 dx. Now the rules of integration. What are the rules of integration? The rules of integration is, let's say that if you are having any power, you need to add 1 to the power and divide by the same power plus c. If you are having a constant, it becomes x. You have to write just with x. So this is the simple rule. So let's integrate. When integrating, you have to integrate all the terms individually. You have to consider them as a single term and get a single term and integrate. Let's integrate. So 4x, let's add 1 to the power, divide by the added power plus 3 over 2, add 1 to the power, divide by the added power minus 8x. This is just 1. So dividing by the same power means same plus c. You got to write c. Okay. So let's simplify now. The final step, 4x to the power 4 divided by 4. So here I'm getting plus 3 over 2 x half divided by half minus 8x plus c. Okay, those who are struggling here to write the answer, I'll help you out to get the answer. So here 4 cancel out, x to the power of 4. Get the calculator, okay? This is not a big deal. So get 3 over 2. Here 3 over 2. 3 over 2. What's the meaning of this one? This line means divide. So give the instruction to the calculator as division. Then this is half. Give half. What's the answer? It is 3. So it's easy. That one is 3. So it is plus 3. It is, yes, it is plus 3 x to the power of half minus 8x plus c. Question 2. Given y minus x equals 4 and 2x squared minus xy equals 8. Show that x squared minus 4x minus 8 equals 0. This is under simultaneous equations. How did I notice or how did I spot that this is under simultaneous equations? So I need to show that x squared minus 4x minus 8 equals 8, and I've been given here two equations. So I need to connect these two equations and I have to show that this equation. When I have to show these equations, I have to show this equation. I notice that in this equation, the equation that I have to show, in this equation, there is no y term. It means I need to get rid of y. I need to eliminate y. It means I have to subject y and I have to substitute that y into an one equation and I need to get rid of y, which means that is the theory of simultaneous elimination method. Right? So if you notice that two equations are given, or if you are asked to build up two equations and form a certain equation, that means you are under the theory of simultaneous equation. So let's see how to do this question. First, you need to go to the two equations that you've been given and label them. So this is the first one, y minus x equals 4. Let's label it y minus x equals 4. I'm labeling it as first equation, equation 1. And I have another equation, 2x squared minus xy equals 8. This is the second equation. Now, analyze these two. You have to go to the equation where there are no powers. It means where the equation which is linear, where there are no powers other than powers which is only ones. Now, in this equation, if I move on to this equation, if I move on to the first equation, can you see y contains the power of 1, x contains the power of 1. If we move on to the second equation, there is a power of 2. So the equations which contain powers with 1, we call them linear. Equations which contains more than power of 1, we call them non-linear. So always pick the equation which is non-linear. Okay, let's get the equation, the first equation. So I'm going to the first equation and I'm subjecting a letter out of that one. So I'm subjecting y in this case. It is easy for me because in this case, can you see there is x squared and there is x. So if I want to substitute a letter into this equation, I have to substitute 2 times here if I'm going to substitute. So if I have to substitute y, I have to substitute only 1 time. If I have to substitute x into this one, I have to substitute 2 times. So I'm picking to substitute y into this equation because I have to substitute once. So I'm going to subject y. Then y equals 4 plus x from equation 1. I'm labeling this equation as equation 3. Right now I'm going to do here, I'm going to substitute this y into the second equation. Then let's write in this way, equation 3 substitute into equation 2. So wherever we get y, the term y, I'm not writing y, instead I'm replacing 4 plus x. So 2x squared minus x. Here I'm getting y. I'm not writing y. Instead, I'm replacing 4 plus x. 4 plus x equals 8. Right now, simplify this one. Then I'm getting 2x squared minus 4x minus x squared equals 8. Now let's bring everything to one side. Can you see we are forming a quadratic equation? So gather everything to one side. So 2x squared minus x squared, I'm getting x squared here, minus 4x minus 8 equals 0. So this is the equation that we've been asked to form. So always look at this one and build up your equation. So part A is done. Let's move on to part B. Part B, we've been asked x squared minus 4x minus 8 is the equation that we've been asked to form. Part B, hence solve the simultaneous equations y minus x equals 4, 2x squared minus xy equals 8. Writing the answers in the form p plus q times root 3, where p and q are integers. So these are integers. Remember that thing, integers to be found. We need to solve the two equations. So let's label this one. Now we can get, by solving out this equation, we can get what the x values are, right? So let's solve the equation x squared minus 4x minus 8 equals 0. Let's solve the equation first, then we can get what x is. So we can use the formula. That's the easiest one, I guess, for the children. Or you can do the completing the square format as well. I'm using the formula because you can't factorize this one. There are no smooth factors. So as soon as you see this one, you should understand that there are no factors. Therefore, you have to move on to the formula or completing the square format. I'm moving on to the formula. Then let's gather the formula. The formula is x equals minus b plus or minus b squared minus 4ac, everything under root 2a. So let's use it. X equals minus 4. So this is something like a rod map. Minus, now b is minus 4. So you need to apply two minus signs, minus b plus or minus square root of b squared, which is minus 4, close the bracket, then squared. Otherwise, your answer will be wrong if you write it in this way, which means if you write it in this way, it is wrong. So you have to write minus 4 within brackets, then squared. Close the bracket and then squared. Minus 4 squared. After that, minus 4 into 1 into c, which is minus 8 again within brackets, all over 2 times a, which is 2 into a. Now use your calculator. Once you use your calculator, let's see what we are getting. So instead of using this one, I'm using modify 3. It is easy. Let's use it and see. 1 equals minus 4 equals minus 8. So it gives me 2 plus 2 root 3 and 2 minus 2 root 3. So I'm getting that answer that is perfect. 2 plus or minus 2 root 3. So these two are the x answers. Okay. Now for each and every x answer, we gotta get what y is. So when x equals 2 plus 2 root 3, we got to get what y is. So pick the easiest equation of y. I'm getting this one. Then y equals, I'm sending this x to this side, then 4 plus 6. It becomes 4 plus 6. So 4 plus x, which becomes 4 plus, here we are having two x answers. Okay, 2 plus 2 root 3 2 plus 2 root 3, which gives out 6 plus 2 root 3. Now, next answer, when x equals 2 minus 2 root 3, let's get what y is. Then y equals 4 plus x, 4, yes, 4 plus x, then 4 plus 2 minus 2 root 3. Then this one gives out 6 minus 2 root 3. So finally, we are getting the final answers. So let's write the answers. X equals 2 plus 2 root 3 and y equals 6 plus 2 root 3 and x equals 2 minus 2 root 3 and y equals 6 minus 2 root 3. Question 3. Find the range of values of z for z smaller than 8, giving the answer in simplest form. When we are given an inequality like this, especially a fraction, okay, the variable is in the denominator, there's a specific way that you gotta do. Most of the students tend to cross multiply. If you cross multiply simply, it's wrong. So I'm going to write the question in this as it is first. 4 over z smaller than 8. Here this z is, in this question, z is not defined as whether it is positive or negative, right? We know that in inequalities, if you are multiplying or dividing any inequality by a negative number, you gotta flip the inequality sign. Let's assume that, let's say that there is an inequality like this, minus 4x is greater than 8. So if I'm dividing this inequality sign by a negative 4, I gotta flip the sign, right? I gotta flip it. So if you are multiplying now, if let's say that you are taking this z to this side, means you are multiplying both side by z. You don't know whether this is negative or positive. It is not defined in the question. Then you are unable to multiply it, right? If you are multiplying, you have to be specific. You have to be sure. You have to confirm it. It has to be positive, because if it's negative, what? Then you have to flip this sign. Therefore, to make it 100% perfect, we multiply both sides by z squared. Then we are okay. We know that squared thing always is positive. Therefore, I'm multiplying both sides by z squared. Then no matter. There is no contradiction. Smaller than into z squared. Then z squared, this one becomes 4z smaller than 8z squared. Then I'm sending this z to 4z to this side. Then I'm getting 8z squared. When this 4z goes to this side, it becomes minus 4z, right? Greater than, because this greater than side is for the 8z squared, 0. So I'm taking out 4z, I'm factorizing. You can use mod 3 and get the critical points. So 2z minus 1. I'm equating to 0 to get the critical point. Then I'm getting z equals 0, z equals half. So you can use the calculator to get these critical points. After that, you have to draw a small sketch. This is a quadratic. So quadratic curve, this is under the format of ax squared plus bx plus c format, right? Any quadratic curve is under this format. So there are two types of curves. depending on the value of A. If A is negative, negative is sad, right? Sad face is this way. Positive is happy, happy is this way. So in this case, A is the coefficient of x squared, which is in this case z squared. It is positive, then it is happy, then we are having a minimum curve. So these are the points that we are getting at roots. So this is z, then this is 0, this is half. So this one said that f of x is greater than. So this is your f of x. This side, this is your f of x. So being at this position, f of x is greater than. You have to go to this side. You have to move to this side to represent greater than. Okay. So to represent this side, so whenever you need to represent the quadratic curve, in the quadratic curve, whenever you represent these two arms, you represent these parts. Okay, never represent this inner side of these two arms. If you are representing this side, it is downside, it is this inner bucket. So we write in this way, x should be smaller than 0 or x should be greater than half. So when you are representing these two arms, never combine the inequality. So you write them as two separate inequalities. When you are writing this inequality, combine it always. The down part, the bucket part always combine as one inequality. The two arms always write them as two separate inequalities. This is the answer then. So let's do part B then. Part B, part 2. We've been given figure 1 shows plot of the line with equation y equals x plus 5. So this is being given as y equals x plus 5. The curve with the equation y equals x times x minus 3. The curve equation is given as x times x minus 3. On the opposite page, there is a copy of figure 1 labeled diagram 1. On the diagram 1, represent the following inequality graphically. X plus 5 smaller than or equals y. Okay. And y should be smaller than or equals x times x minus 3. So we need to combine these two inequalities. You need to recognize the region. X plus 5, y should be greater than or equals x plus 5. So we know that y is greater than means being on this line, the whole region which is greater than above the line. The whole region greater than above the line. But there is a restriction. Not you can't pick the whole region. There's a restriction. As well as considering the curve, you have to come down from the curve. Being on the curve, you have to get all the region that is below the curve. Now, as well as from the line, above the curve, from the curve, below the curve. You need to get the common region that represents this one. Being on the line, above the line, being on the curve, below the line, then you need to get the common region. Then when getting the common region, we can recognize that this is the region, right? So if I shade it, it would be somewhere here. This is the region that we are getting. But there's another part. For x should be greater than or equals minus 2. Then there is another restriction. Not everything common this. Not everything common this inequality only. There is another restriction. Pick common for this part as well. Then you have to recognize what this is. So let's draw that line. That line is this one. So if I draw that, it is this one. So let's get everything greater than that one. Then if I shade it, it would be like this. So above the line, below the curve, I'm having this part as well as this part. Now, okay, greater than the line, below the curve. We can't get this part because this is here. We can't get this one. This is not below the curve. The below the curve is here, then it is not greater than 2. So we have to get everything here as well. That's how we do it. Question 4. The point A minus 1 comma 8 and the point B 7 comma 2 lie on the line L1. Part A, find an equation for L1 in the form ax plus by plus c equals 0, where a, b and c are integers. So we have to find an equation for L1. There is a point A minus 1 comma 8. So I'm getting point A minus 1 comma 8 somewhere here. Randomly, let's label minus 1 comma 8. So you have to have an idea, assuming that this is x and y axis. Okay, just without getting it wrong, just have an idea of the sketch of x and y axis. So this is minus 1 comma 8. Then let's get b 7, positive 7 in the x axis is somewhere here, 7 comma 2. So 7 comma 2 is somewhere here. I'm getting it over here, b, point b, 7 comma 2. Right, let's join this a and b, then it would be a straight line. Now we need to form the equation of this straight line. We need to get the equation. So to form the equation, we know that the equation format is y minus y1 equals m times x minus x1. Then I need to follow this format. To follow this format, I need y and x, they are fixed. They are always there in the equation. Y1, x1 means the coordinate, value of the coordinate. Then you've got to have a coordinate. So I need to have a coordinate rather than one coordinate. I'm having two coordinates. So I can pick a or b, coordinates of a and b. So I'm done with coordinate. I'm having one coordinate. So I need to figure out what the gradient is. How do we get the gradient? M equals, I know that for any gradient I can get m equals y2 minus y difference, because when we are having two coordinates, this is the formula, y difference over x difference, x2 minus x1. So let's get this one as x1 y1. Let's get this one as x2 y2. Let's substitute the values into this one. So y2, which is 2, y1, which is 8, x2, 7, minus 1. So let's plug in the values into the calculator. Fraction 2 minus 8 over 7 minus 1 equals minus 3 over 4. So this is the gradient, minus 3 over 4. So we are having the gradient, we are having a coordinate. It is so easy. Now let's form the equation. We can form the equation now. Y minus y1. Let's get the coordinate of a, which is 8, m times, which is minus 3 over 4, x minus x1 minus 1. Let's simplify because there's a certain format that you are asked to leave your answer, which is ax plus by plus c. So you have got to bring everything to one side and there are no fractions as well. So I'm getting rid of this denominator. 4y minus 32 equals minus 3x. Here minus 3. Because minus minus becomes plus 3 into minus 3 minus 3. So let's bring everything to one side. Then 3x plus 4y minus 32 minus 3 becomes plus 3 becomes minus 29 equals 0. This is the answer for part A. Let's move on to part B. The line L2 passes through A and is perpendicular to L1. Cuts the x-axis at the point C. Find the coordinates of C. So there is another line L2 which passes through the point A and it cuts the x-axis at point C. So if you get that line L, it passes through like this point A and it cuts the x-axis somewhere here C. Let's label this one as C. This is C, which is now if you want to see, this one is your x-axis. Let's get this one. This is your x-axis now. This is the x-axis. This is x-axis. So here somewhere here y-axis as well. If you want, you can label it. So we know that on the x-axis, no matter where you go, on the x-axis, y-coordinate is 0. So we formed the y-coordinate of this point C. We have to get what? The x-coordinate. So to get the x-coordinate, since these two lines are perpendicular to each other, this is a hint. Whenever you've been given two lines are perpendicular to each other, as soon as it's given, label this thing M1 and M2 condition. This is so important. This is line L2. What's the meaning of M1, M2? The meaning of M1, M2 is once you multiply M1 and M2, once you multiply the two gradients or the product of the two gradients equal to minus 1. If you have two gradients, M1 into M2 equals minus 1. So we got the gradient M1. M1 equals minus 3 over 4. So let's substitute that one. Minus 3 over 4 into M2 equals minus 1. Therefore, M2 equals 4 over 3. Right, we have the gradient of this line now. We got it 4 over 3. And we have a coordinate where this L2 passes through, which is A. Then we can form the equation. Let's form the equation of L2. So y minus y1 equals m times x minus x1. We know that y and x fixed there. y1, x1 means coordinate. You have to substitute the values of your coordinate into y1 and x1. m1, the gradient of the line. So y minus, you got to get the coordinate, which is the coordinate of A, y1, which is 8, equals m 4 over 3 x minus x1 minus 1. So if you simplify this one, 3y. So I'm not simplifying, I'm keeping it in this way. Minus 8 equals 4 over 3x plus 4 over 3. So this is the equation of L1. Let's just keep it in this way. Now I need to get the coordinate of this one. I know that at this point y is 0, right? Y is 0. So I'm making this 0 here, y is 0. Then when, let's write when y equals 0, I need to get what x is. When y equals 0, we need to get what x is. So 0 equals 4 over 3 x plus 4 over 3. Then 4 over 3x equals minus 8 minus 4 over 3. Therefore, 4 over 3x equals, here 3 into 8, it is 24, 24, 28 minus 24, 28 over 3, 3 cancel out, x equals minus 7. So we are getting the C coordinate 0, comma minus 7. Let's move on to part C. Hence find the area of triangle ABC. So there is triangle ABC. Let's join ABC. So this is ABC. And we know that AC and AB, they are perpendicular to each other. So area of triangle ABC equals half into base into height. So what is half? What is your base? We know that these two sides are perpendicular to each other. Then one side is base, one side is height. So let's get AC as your base, AB as your height. Then we need to get the length of AB and length of AC. So how do you get the length of any line? The length formula. How to get the length formula? So length equals, you should memorize the length formula. Length equals x2 minus x1, the whole thing squared, plus y2 minus y1, the whole thing squared, the root of whole thing. Then AB equals AB, we are having two coordinates. So simply we can get it 2 minus 8 squared plus 7 minus 1 squared. So once we plug in the values, we are getting 10. Same way, AC equals, once we plug in the values, AC 8 minus 0 squared plus minus 1 minus 7 squared, we are getting 10 there. Then they are same sides. So let's plug in the values into the area formula now. Half into base into height. So half into base into height, which gives out 50. Then area equals 50. Question 5. Figure 2 shows the logo for the tourist board of an island. The logo consists of a sector BODCB of a circle center O joined to a triangle AOD. Given that ABO is a straight line, OD equals 3 centimeters, AD equals 8 centimeters, angle AOD equals 2.5 radians. Show that angle ODA is 0.415 radians. We need to show that ODA is 0.415 radians. Let's label that given information here. OD equals 3 centimeters. 3 centimeters. AD equals 8 centimeters. AOD equals 2.5 rad. AOD 2.5 rad. Show that ODA. ODA. We need to get the value for this one. So we have a triangle here. ODA is a triangle. We have 3 lengths and 1 angle. When we have 3 lengths and 1 angle, we can find out 1 angle using sine rule. 2 lengths, 1 angle, we can find out another angle using sine rule. So let's apply sine rule, get another possible angle. It is not exactly the angle that we need to prove. It is not exactly ODA. Let's see which angle that we can get here. So we have this length, therefore we can get this angle. The angle which is opposite to this one. Let's label the opposite lengths for this one. So if I get this one, this is the opposite one. For this length, this angle is opposite. For this length, this angle is opposite. So I can get obviously this angle. So if I can get this angle, then I can apply angles on triangle and get this one finally. That's how we will be able to get it. So let's apply sine rule. So finally we can get sine rule. So I'm going to apply the sine rule. Let's get it in this way. Sine OAD. Sine OAD over its opposite length, which is 3 centimeters. Since we need to get this angle, start off with the angle that you need to get. Then it is easy. Equals, then another sine angle. Sine 2.5 over its opposite length, which is 8. Now let's cross multiply. So sine OAD equals 3 times, I'm taking this 3 to this side. So 3 into sine 2.5 over 8. Right, now let's get rid of this sign. I need to get rid of sine. I need to send this sine to this side. Then I can get what this angle. Then OAD, angle OAD equals, when sine goes to this side, it becomes sine inverse. Sine inverse 3 into sine 2.5 over 8. So let's use the calculator and get it. Use your calculator. Straight away apply it. Make sure your calculator is in the format of radians. 3 into, apply sine inverse first. Shift, sine inverse, fraction key, 3 into sine 2.5, sine 2.5, close the bracket, over 8. Again, close the bracket, equals. It is 0.226. So, equals 0.22635. It goes on. So, we need to get ODA. Here, we need to get this angle. We found this angle. We got this angle. Now we need to get this one. We know that all 3 angles of this triangle, they add up to 180, or in radians, it is pi. Therefore, to get ODA, ODA equals, since all 3 angles add up to pi minus 0.22635 minus, which is the given angle equals 2.5 minus that much as well, 2.5 equals, let's get the calculator and plug in again. So pi minus 0.22635 minus 2.5 equals 0.4152. 0.4152. So once we round it off to the third significant figure, the answer is 0.415. So that's the required answer. So we are done with part A. Let's move on to part B. Part B, find the total area of the logo in square centimeter. So we know that this much is 8 centimeters now. This is 8 centimeters. And this is 3 centimeters. And this is 2.5. And this is 0.415. And this is we got as 0.226. Right, that's it. Now, how do we get the total area? What's the formula of the sector area? So, sector area formula, what is the area formula? Sector area equals half r squared theta. Remember, theta has to be in radians. Then I need to get theta. This is the sector. This is the sector. So sector area is to get the sector area. This is your theta. Then I can write theta equals, okay, 2 pi minus 2.5. Why? Because this whole angle, it add up to 360. This is a circle. So the circle is 360. In radians, it is 2 pi. Then to get this angle, it is 2 pi minus 2.5. Then A equals half. R is given as 3 squared into 2 pi minus 2.5. So this is the sector area. This is sector area. Now we need to get the area of the triangle. Area of the triangle. To get the area of the triangle, we know that it is half AB sine C. So half A is this one, B is this one, C is in between angle. If you move on to this one, you don't know this side. Therefore, you can't get this one as A or B. You have to have two sides and in between angle. Therefore, A, if you can get this one as A, this one is B, and this one has to be necessarily be your C. So A is 3, B is 8, and sine 0.415. Now we need to add these to the total area of the logo. So total area of the logo, total area equals, let's add them. So half, which is 0.5 into 3 squared into 2 pi minus 2.5, close the bracket, plus half 0.5 into 3 into sine 8 sine 0.415 equals 21.86. So total area 21.86. So we need to leave our answer to one decimal place. If you don't leave your answer to the first decimal place, again you are losing 1 mark. It is 21.9 squared centimeters. That's part B. Let's move on to part C. Part C is find the perimeter of the logo. So we need to get the perimeter of the logo. We know that. Now again, this is 8. This is 3. This is 2.5. 0.415. 0.226. Right. This is the information that we already know. Now to get the perimeter, we need to have this length, right? We need to get the arc length. Okay, let's get the arc length first. Arc length. Arc length equals, how to get the arc length? We call this one arc length. It is one part of the circumference here, arc length. So arc length, there is a formula, arc length equals r theta. R is given in the question, which is 3. Theta is, this is your theta. We got it as 2 pi minus 2.5. Now we got arc length. Let's leave it like that. Or you can simplify and get it as well. So arc length is done. Now we need to get this one. It is 8. That is also the part of the perimeter. And we need to get this one. How do we get this one? How do we get it? You can either you can find the full length first, full length, and you can subtract that much from this much from the full length. So let's get OA first. To get OA, I'm using cos rule. So OA equals, you can use sine rule as well. So I'm using cos rule or sine rule, anything. OA equals 3 squared. Here, this is the side, this is the side, this is the in-between angle. So 3 squared plus 8 squared minus 3 into 8, 2 into 3 into 8 into cos in-between angle, which is 0.415. This is OA squared. To get OA, I need to get the root of this one. So 3 squared plus 8 squared minus 2 into 3 into 8 cos 0.415. The whole thing, we need to get the root. So let's apply the values into the calculator. Root of 3 squared plus 8 squared minus 2 into 3 into 8 into cos 0.415. It is 5.3920. 5.3920. Right. Now we are having this one. So let's get the perimeter now. Perimeter equals, so we have the arc length, which is 3 times 2 pi minus plus 8 plus the full length, which is 5.39, minus this length, which is 3. So use the calculator and get the answer. 3 into 2 pi minus 2.5, close the bracket, plus 8 plus open bracket 5.39 minus 3, close the bracket, equals 21.73. So 21.73, which gives out 21.7. Question 6. Figure 3 shows a sketch of the curve C with equation y equals f of x, where f of x is a cubic function in x. The curve C cuts the x-axis at minus 2, 0 and cuts the y-axis at 0, 10. Touches the x-axis at 5, 0 as shown in figure 3. Part A, deduce the roots of the equation f of 1 over 3x equals 0. So we need to get the roots of the equation f of 1/3 x equals 0. What is this? This is a bit of transformation and cubic curves. How do we do this one? Here y equals f of x is given. When y equals f of x is given and f of 1/3 of x is given, you need to analyze these two. Always analyze what happened to y equals f of x, which means if there is any change to y equals f of x, it means there's a transformation's been taken place. You have to analyze what's the change for f of x. So original one, earlier it was f of x, now it has become to f of 1/3 x. Earlier it was f of x, now it has become f of 1/3 x. It means this x has become 1/3 x. F of x, it has to be f of x. Now it is f of 1/3 x, right? So can you see this change? It is inside bracket. Here it is inside bracket. If the change is outside bracket, it will be like this. It will be like this. Here, this is out of brackets. Now this is inside bracket. So if you spot this difference inside bracket, always x coordinate gets changed. If the change happens inside brackets, always x coordinate gets changed. Now in this case, inside brackets, because x coordinate is divided by 3, right? Divided by 3 in this case. So inside bracket, then x coordinate gets changed. By how? If x coordinate gets changed by anything, you have to apply that change in opposite way. That's the difference of x coordinate. If anything happens to x coordinate, you have to apply that change in opposite way for the transformation. So in this case, the transformation says that this is f of 1/3 x. But when applying this transformation into this one, for that coordinate, you have to multiply by 3. This is stretch because this is multiplication. When you spot a multiplication or division, it is stretch. You have to stretch the curve. So this is stretch. The scale factor becomes scale factor. This is stretch. Scale factor. It is 3 in horizontal axis, which means x coordinate gets changed. X coordinate should be multiplied by 3. Okay, not by 1/3. you have to apply always opposite way. So the transformation says that 1/3 of x, but when we are getting it, you have to do it multiplied by 3. So let's see how to do it. Now, this is the coordinate. So this is the coordinate. Deduce the roots of the equation 1/3 of x. So these are the roots now. You should know what roots are. Let's say that this is a root and this is a root. Roots are where the curve cuts the x-axis or touches the x-axis. So roots in this case in the original curve, the one root equation of one root is x equals 2, right? X equals minus 2, x equals 5, right? These are the two equations. X equals 5 and x equals minus 2. Now we need to write the equation for these two. How do we write the equation for these two? So when writing, now when applying the transformation for this one, now we know that we need to multiply this one by 3 because this is dividing by 3, then I'm multiplying by 3, then x equals minus 2 to be multiplied by 3, then it will be x equals minus 6. So one equation is x equals minus 6. The other one would be x equals 5. Again, the scale factor is 3, then x equals 15. Then the equation of the roots would be x equals minus 6, x equals 15. Next one, part 2. This is the transformation. Now, whenever you see addition, subtraction, it is always translation. In this case here, this is subtraction. So it is translation. Again, inside bracket. It is again inside bracket. Here, inside bracket. Again, x-axis. Again, x-coordinate. So when anything happens to x coordinate, you have to apply it opposite way. Then this is minus 3. Then you have to add 3. Then let's say that we are having here root minus 2. So x coordinate is x. You are having here minus 2. So minus 2. Then we have to add 3. Then it will be plus 1. Then the new equation would be x equals 1. The other one would be, it is 5, then 5 plus, you have to add 3, the new equation would be x equals 8. So these are the two equations. Here you have to write, deduce the roots of the equation. This is the way how we do it. Next one, part B. So how do we do part B? Find an expression for f of x. So this is f of x. F of x is our original curve, which is a cubic curve where it cuts the x-axis at minus 2 and touches the x-axis at x equals 5. Find an expression for f of x. You should leave your answer in factorized form. So remember, for any cubic curve, the standard equation, you should memorize it. F of x equals, memorize this one please. F of x equals k. K is any constant. There can be any number as k. X plus a, x plus b, x plus c. So this is a standard equation. Now for a straight line, there's a standard equation, right? Y equals mx plus c. Y equals mx plus c. There is a standard equation for a quadratic. When a quadratic question comes, I'll explain it. This is the standard equation for a cubic one when we are writing in factor form. This is the standard equation when we write as a factor form. So now we know what the factors are. So let's substitute what the factors are here. Let's substitute the values what here in A, B, C, we can substitute the values of these factors. So f of x, I know that instead of f of x, I can replace y there. K, we don't know what the value here is. So x plus a, I know that one root here is minus 2. So I have to reverse it. So I can write x plus 2. Then only I am getting x equals minus 2, right? So when converting it a factor, I need to write it in opposite way. So other one is touching. It means there are double roots. So therefore, when writing it, x minus 5, this is double root, repeated roots. So x minus 5, it repeats. So this one is the x minus 5 squared. Right, we need to get what k is. We don't know what k is. So once we get k, we are done. So for that, we've been given here coordinate, which is 0, 10. Let's substitute 0, 10 into the equation. So y equals 0, k times 10 plus 2. Sorry. Here, y equals 10, k, x equals 0, 0 plus 2, 0 minus 5 squared. Then 10 equals k times 2 into 50. Then k equals, how much is k then? Here 50 into 200. Here 50, which is 1 over 5. Then k equals 1 over 5. Then we can finalize our equation as y equals 1 over 5 x plus 2 x minus 5 squared. So this is part C, part B. Let's move on to part C. Part C, use algebra to find exact x coordinates of the 3 points of intersection. Part C. The curve C intersect the straight line y equals 10 times x plus 2 at exactly 3 points. Use algebra to find the exact x coordinates of the 3 points of intersections. Right. Now we have a straight line here, we have a curve here. There are points of intersections. Points of intersection. As soon as you get points of intersection, now there's a curve like this. There's a straight line here. Points of intersections are, these are the 3 points. So we need to get the solution for, which means we need to get the x coordinate of these 3 points. So let's see how to get these x coordinates. Let's write down the 2 equations that we've been given. Y equals 10 times x plus 2. The other one is y equals 1 over 5 times x plus 2 x minus 5, the whole thing squared. Now this is y points of intersection. We can equate them together. Let's equate them together. 10 times x plus 2 equals 1 over 5 x plus 2 x minus 5, the whole thing squared. Now I'll give you and I'll tell you something. 99% students, they tend to cut this off. Never cut like this. Never divide anything, any number when you are solving out an equation. Get this as a factor, otherwise you will miss out a solution. Okay, you don't miss out a solution. You need to factorize only. You can't divide anything out. So I'm bringing everything to one side. Bringing everything to one side. I'm equating to 0. So 1 over 5 x plus 2 x minus 5 squared minus 10 x plus 2 equals 0. Now, if you cut that way, you are missing out one solution. Therefore, I am factorizing. Can you see x plus 2 is common for this equation? I'm taking it out as a common factor. Then 1 over 5 x minus 5 squared is common here, minus 1 equals 0, minus 10. Then I can write x plus 2 equals 0, or 1 over 5 times x minus 5 squared minus 10 equals 0. X minus 5 squared equals 50. So x squared minus 10x plus 25 equals 50. X squared minus 10x minus 25 equals 0. So apply the formula and get the solution. Then x equals minus 10 plus or minus b squared minus 10 squared minus 4 ac a minus 25 over 2a. Now use the calculator mode. You can get the answer. So x equals 5 plus or minus 5 root 2. So these are the solutions. Question 7. The curve C has equation y equals 2 over 3x cubed minus 8x squared plus 43x minus 2 over 3. Part A. Show that dy by dx can be written in the form p times x plus q squared plus r. So this format is, it is very familiar format. This format is complete the square format. It means that we need to get dy by dx and convert dy by dx into the form of complete the square format. So let's get what dy by dx first. So part A, dy by dx equals 2 over 3 into 3 x squared minus 2 into 8 x plus 43. So let's simplify this one. 3 cancel out. Then I'm getting 2x squared minus 16x plus 43. Now I need to convert this one into complete the square format. So I'm doing it manually. You can use the formula as well. It is easy to use the formula, but I'll show how to do it manually. So I'm factorize this one. I'm taking out 2 first. Then I can write this one x squared minus 8x plus 43 over 2. Next step is 2 times x minus 4, the whole thing squared, minus 16. So we need to, whatever you get here, you need to square it and subtract. minus 16 plus 43 over 2. 2, 2 times x minus 4 squared. Once we plug this into calculator, we are getting 11 over 2. So once we multiply this one 2, then 2 times x minus 4 squared. Once we multiply this into this 2 and 2 get cancelled out, it becomes 11. So once we write it into the form of the complete the square format, I'm getting this one. So we are done with part A. Let's move on to part B. Part B is given as hence state the minimum value of dy by dx. So when we are given the complete the square format, this is the format, the minimum value is the y value of this one. So when we are having a quadratic curve, this is the minimum value. So if you are having here, this is the y value, minus q is the x value, r is the y value. So by using this one, we can get the minimum value. So depending on this curve, part B first part, the minimum y value is 11. Part 2, the value of x at which this minimum value occurs, this one, x equals what? So it is 4. At x equals 4, we are getting the minimum y value, which means the minimum gradient, because this is dy by dx. We are drawing the curve for dy by dx. For dy by dx, we are getting, this is the, now if we draw a curve here, this is dy by dx. Now this is, if we draw, this is the point, this curve, this is dy by dx value, dy by dx we are getting 11. This is the x coordinate. X coordinate we are getting 4. Part C, given that S is the point on C. So there is a curve C, S, there is a point S. S is the point on C at which the gradient is minimum. Then this point is the minimum point. We know that gradient at this point m equals 11. We form it. Minimum. Find the equation of the tangent to C. So there is a tangent. We need to get the equation of the tangent. So the any equation y minus y1 equals m times x minus x1. Then we need to have a coordinate. So given that S is the point on C at which the gradient is minimum. So the gradient is minimum. We got what x is. X we got as 4. We don't know what y is. We need to get what y is. We got what x equals 4. Then by using the equation of the curve equation, y equals 2 over 3 x cubed. It's given in the question 8x squared plus 43x minus 20 over 3. So let's substitute this x coordinate into this equation and get what y is. 2 over 3. Here 4 cubed minus 8, 4 squared plus 43 into 4 minus 20 over 3 equals, let's plug these values into the calculator and get it. 2 over 3 into 4 cubed minus 8 into 16 plus 43 into 4 minus 20 over 3. We are getting 80. So the coordinate is 80. So we have the S coordinate now. S is 4, 80. And we have the gradient, which is 11. We found it. Now we can form the equation of the tangent. So let's substitute the values. Y minus 80 equals gradient is 11, x minus 4. So we need to leave the in the form of this one. Simplify. Y minus 80 equals 11x minus 44. Y equals 11x minus 44 plus 80. It is 36. Question 8. A curve C has the equation y equals f of x where x is greater than 0. A point P lies on C given that f dash of x equals 4x squared plus 6 over x squared minus 4. The equation of the tangent to C at P is y equals 10x minus 6 root 3. Part A, Part 1. Verify that root 3 is a possible x coordinate of P. Right, let's do part 1. So there's a curve which is f of x. The equation of curve C is given as f of x and there's a point P and there's a point P and there's a tangent. The equation of the tangent is given as y equals 10x minus 6 root 3. And we've been given here f dash of x. F dash of x equals 4x squared plus 6 over x squared minus 4. Right? Now we need to prove that, verify that root 3 is a possible x coordinate of P. We need to prove that this root 3 is a possible x coordinate of P. So what is f dash of x? F dash of x is wherever you've been given f dash of x is the gradient formula. So not like straight line. When there's a straight line, no matter where you get, the steepness is same. The gradient is same. But when you are getting a curve, no matter where you go, the gradient is different. Each and every point, the gradient is different. Therefore, there is a formula to figure out what the gradient is of this curve when we are getting the x coordinate. If you have the x coordinate of each and every particular point, then you can get the gradient of each and every point. So in this case, we've been given what the f dash of x, which means the gradient formula, or dy by dx is given. The gradient formula is given. Then if you know what the x coordinate is, you can get what the gradient is. In this case, you have to prove that this is a possible x coordinate. So if you have here what the gradient is, if you can substitute this root 3 here, if you are getting that the gradient of that one, then you are done. So if we can figure out what the gradient at this point is, we can do that thing. So what's the gradient of this point? The gradient of the tangent is as the same as the gradient of the curve at this point. So what's the gradient of the tangent? Let's move on to this one. This is y equals mx plus c. Let's get this one. Y equals mx plus c. Then the m represent with 10. Here the m represent with 10, then the gradient of this tangent is 10. Then the gradient at this point is 10. Then I can write 10 equals 4x squared plus 6x squared minus 4 at P. At point P, the gradient is 10. Now we need to verify that root 3 is possible x coordinate. You need to verify it. So let's substitute that root 3 into this one and check whether we are getting 10 at this point, because we know that gradient is 10 at this point because the gradient of the tangent at P is 10. The gradient of the tangent is 10. No matter where you go, the gradient of the tangent is 10, but this is the tangent point. Then at this point, the gradient of the curve is 10. Then we can equate 10 equals this one. So by solving out, by just substituting that root 3 into this position, if you are getting here 10, then you are done. Let's substitute root 3 into this one and check whether we are getting for this side 10. So 4 root 3 squared plus 6 over root 3 squared minus 4. So use your calculator. 4 into root 3 squared plus 6 over root 3 squared again, which means 3 minus 4, 10, which means root 3 is a possible x coordinate. Now let's move on to part 2. Part 2. F dash of x equals 4x squared plus 6 over x squared minus 4, which is given. The equation of the tangent is y equals 10x minus 6 root 3. Part 2, find using algebra the other possible x coordinate of P. So we know that we have to get the other possible x coordinate of P. I know that the gradient at P is 10 now. So we can equate it to the gradient formula 4x squared plus 6 over x squared minus 4. Now by solving out this equation, we can get the possible x coordinates. So one would be root 3 and we can figure out what the other coordinate is. So let's solve out this equation. So I need to get rid of this denominator. Therefore, I'm multiplying the whole equation by x squared. Then 10x squared equals 4x to the power of 4. When multiplying, we need to add the power. Then 4x squared into x squared. We add the powers. Here 6 x squared cancel out minus 4x squared. Here let's bring everything to one side. 4x to the power of 4 minus, I'm taking this one to this side, then minus 10x squared minus 4x squared, both together minus 14x squared plus 6 equals 0. So I'm dividing the whole equation by 2. Then 2x to the power of 4 minus 7x squared plus 3 equals 0. Now this is a quadratic embedded equation. So I'm getting x squared, I'm equating to y. Then I can rewrite this equation in terms of here x squared, I'm equating to y. Then this one becomes 7y. Here x squared equals y. Then x to the power of 4 can be written as x squared to the power of 2. Then this would be x squared to be replaced with y. Then it would be y squared. So here we are writing 2y squared because this is x to the power of 4 minus 7y plus 3 equals 0. So let's solve out this equation. Then we can get what y is. When getting factors, so you can straight away use factors. 2y minus y 1 times y minus 3. Get the factors using the calculator. Then I'm getting y equals half, y equals 3. Now let's substitute what x is because we need to get what x, not y. So I got y as x squared. Then I'm writing x squared equals half, x squared equals 3. Then here x equals plus or minus half. Here x equals plus or minus 3, root 3. Here also root 3, root half. Now at the beginning we've been given that x has to be positive 1. Therefore x has to be root positive half, root positive half, this one, root positive 3. So we form this one using, now we need to get this one. This is the other possible x coordinate. So we need to get the y coordinate as well, other possible x coordinate. Then this is the answer. You have to exclude negative answer because we've been asked to get, we've been instructed that x is greater than 0. Let's move on to the other part. Part B, find f of x, writing your answer in simplest form. You must show each stage of your working. Oh, we didn't do part B. Yes, this is part B. Given that x coordinate of P is root 3, find the equation of the normal to C at P. Okay, now this is the thing. This is f of x. This is the tangent at P. This is the normal. When we are having normal, this is tangent, then this is M1, this is M2. The gradients, the product of the gradients, once you multiply them, the product of the gradients equal to -1. So we have the equation of the tangent we've been given in the question. It is y equals 10x minus 6 root 3. Therefore, M1 equals 10. Then M2 we can get minus 1 over 10 because here M1 into M2 equals minus 1. M1 we have 10. M2 multiplied minus 1. Then M2 equals minus 1 over 10. That's how we are getting minus 1 over 10. Now we have the gradient. We have this x coordinate of this one we've been given here. It is root 3. We don't know what y coordinate is. Now we need to get what y coordinate is. For getting y coordinate, we have an equation. Let's substitute that x coordinate into this one and get what y is. So I'm substituting y equals 10x minus 6 root 3. Then 10 into root 3 minus 6 root 3 equals 10 root 3 minus 6 root 3, which becomes 10 minus 6, which is 4 root 3. So the coordinate comes as root 3, 4 root 3. then we can get the equation of the normal y minus y1 times equals m times x minus x1. So let's form the equation y minus y1, which is 4 root 3, equals m. We got it as minus 1 over 10 x, which is root 3, minus, x, you have to go ahead as x minus root 3. So you can simply keep the answer like this because you haven't been asked a certain format. Part C. Find f of x, writing your answer in simplest form. You must show each stage of your working. F dash of x is given in this case. F dash of x is equal to 4x squared plus 6 over x squared minus 4. The equation of the tangent is given and the coordinate of p, x coordinate of p is given, and we've got what y coordinate as well. So since f dash of x is given, we know that when the differentiated formula is given, how to get the original equation. F dash of x is given. Once we get the f dash of x, we can get f of x by integrating it. F dash of x is given. We can get f of x by integrating it. This is the formula. So let's integrate this one, f dash of x. So I'm going to integrate this one, f 4x squared 6 over x squared minus 4, all everything dx under dx. Right, now here there should be a certain format that we will be able to integrate this one. We can't have any x variables in denominator. You need to bring everything to the numerator. How do we bring? When we bring x variables to the numerator, you need to change its power. Power should, when the power is in the denominator, when you bring it to the numerator, its power gets negative. So let's rearrange this one first of all. 4x squared plus 6x to the power of minus 2 minus 4. Now we'll be able to integrate 4x cube, add 1 to the power and divided by the added power. Let's simplify. Right, we know that this is y. Now we need to get the constant. For getting this constant, we need to substitute x and y coordinate. We are having here x and y coordinate. Let's substitute x and y coordinate where this curve passes through and get what the constant is. So I'm going to substitute x and y coordinate into this one. Here, this is x, this is y. Let's substitute this one. So 4 root 3 equals 4 over 3 into x cube, which means root 3 cube minus 6 over root 3 minus 4 into root 3 plus c. Let's simplify this one. 4 times root 3, 4 into 3, 4 over 3 root 3 cubed means root 3 into root 3 into, you can use a calculator, you root 3 into root 3 into root 3, root 3 into root 3, 3 root 3. So here 3 cancel out. This becomes 4 root 3. Here 4 root 3 cancel out. Then C equals 4 root 3 plus 6 over root 3. Then C equals root 3. I'm taking common denominator. Then 12 plus 6, which becomes C equals 18 over root 3. So you can rationalize this one, then you will get 6 root 3. Question 9. Figure 4 shows a sketch of part of the graph of the trigonometric function with equation y equals f of x. Write down an expression for f of x. So we know that this is a trigonometric function. This is a curve of trigonometric function. Then there are 3 trigonometric functions that we have to deal with P1. These are y equals sin x, y equals cos x, y equals tan x. So this is not obviously y equals tan x. So we can exclude it. This is either y equals sin x or y equals cos x. So this is something like y equals cos x, because can you see this one? The shape of this one. Shape of this one is y equals cos x. So this is the original curve of y equals cos x. This is the original curve of y equals cos x. So wherever you see this one, you have to be prepared with this is y equals cos x. So there is a shape of this one here. Can you spot this one? So I can spot this part. So this is original one. I can see that original part flipped over here. So original one is this one. It is flipped over here. So whenever we get flipped over one, it means there is a reflection embedded. Reflection. Original one embedded here. It means reflection is happening. Reflection. So you need to identify there is a reflection. Reflection in the x-axis. Can you see this part goes up here? There is a pointed one here and this part is down. So reflection is obviously there. So I know that here the minimum value of the cos curve is -1, maximum is 1. Maximum value is 1, minimum value is -1. But when analyzing this one, always transformation means analyzing. You have to analyze the original one and the transformation one. So when analyzing the original one, it's supposed to be +1. Now it is 10. So what's the difference? 10. It is 10. So I can see that it is y equals cos x is the original one. Now it is something flipped over. If it is reflection in the x-axis, then it has to be y equals minus cos x, because in the x-axis we write it in this way, y equals f of x. If there is a reflection in the x-axis, we write it in this way. Then you need to include that minus sign in front of cos x, right? So minus cos x. But the maximum value, it comes as 10. It means there is a stretch. Stretch is also there. Then I can write here minus 10 as well. Minus 10. Then we can write it as y equals minus 10 cos x. So when there is transformation, always analyze. You have to recognize what the original one always and analyze with the original one. Analyze with the original one. Right. Part B. On diagram 1, copies of figure 4 labeled diagram 1 and diagram 2 can be found on the following pages. On diagram 1, sketch a graph of the curve with equation y equals 10 minus x squared. Y equals 10 minus x squared. Let's go to that one. This one. Now we need to sketch y equals 10 minus x squared on this one. Y equals, we have to sketch y equals 10 minus x squared. Right? We know that this is a quadratic one. Quadratic equation. So when sketching a quadratic equation, we need, first thing we need to get roots. We have to have roots and we need to realize whether it is a minimum one or maximum one. And we need to have maximum. We need to recognize whether it is minimum, maximum, and we need to have roots. We need to have y-intercepts. We need to have the coordinate of minimum and maximum as well. Those three things we need to have. Let's see how to get those things. Now, this is in front of x squared. We have minus sign. It means this is maximum curve. So it is, since it is negative, a is negative. Now we know that ax squared plus bx plus c. Depending on this one, if a is positive, if a is negative, we can say that a is positive, happy, positive, happy, happy face. A is happy, A is negative, sad face. So this is sad because here x squared is negative. So this is, the face is sad. Then roots. How do we figure out root? Roots means where this curve cuts the x-axis. These are roots. How do we figure out roots? We know that when the curve cuts the x-axis, y coordinates are 0. Then when y equals 0, when y equals 0, you need to get what x is. Then 10 minus x squared equals 0. Then x squared equals 10. Then x equals plus or minus root 10. Right? So these are the positions where this curve cuts. Here this is root 10 minus root 10. This is plus root 10. Right. After that, y-intercept. So y-intercept is when x equals 0. When x equals 0, y equals what y is. When x equals 0, so y equals 10. Then y-intercept is 10. So let's sketch it now. Let's sketch it. So let's get the calculator. I'm getting this exact value of this one, root 10. Root 10 means 3.16. Here we are having in terms of pi. So pi means 3.14, right? It is so exactly here pi. So we can plot it here, right? And the other one is here. We can get it like this. Okay, we are getting a curve like this. That is part 2. Now let's move on to part C. Part 2, there's one more part B. Hence, find the number of solutions of the equation 10 minus x squared. Number of solutions. So can you see there are number of solutions means number of intersecting points 1, 2. There are two intersecting points. No matter how many times that we are going down, we do not get intersecting points because this curve, it gets here, turning points from here, here. So there are no any intersecting points because the curve, it gets furthermore going downwards, and this curve, it is getting here, turning from this point onwards here and here. So no more turning points, therefore we don't get any more turning points. That's it. Therefore there are only two intersecting points. Part C. On the diagram 2, so for this one there are only two intersecting points. Part C. On diagram 2, sketch the graph of the curve with equation y equals tan x. Y equals tan x. Let's go to that one. Y equals tan x. Diagram 2. Y equals tan x. When sketching y equals tan x, we know that this is the line of, there should be line of asymptote. After that, we need to sketch it in this way. So it is a curve from 90 to from 90 to 90, from 0, here it passes through 0, 90 to 90. Every 180, the tan curve gets repeated. Like this. So after that, we need to get again intersecting points. Part 2. Hence, find the number of solutions of the equation 100 minus 100 pi to 100 pi. Giving reasons for answer. Let's see how many intersecting points. Since now we need to get 100 pi to minus 100 pi. Let's see how many intersecting points that we are getting. Here, now this is one intersecting point for pi. Here, can you see two? Let's get the number of intersecting points to pi. Here we are getting 1 to this side. To this side, we are getting here, this is the curve. Let's say that for this side, 1, 2. For 2 pi, we are getting two intersecting points. Okay. So we are getting 2 intersecting point for 2 pi. Two pi, 2 intersecting point. Then for pi, 1 intersecting point. For 100 pi, 100 intersecting point. Then for 200 pi, 200 intersecting point.